I don't know how much of the recording is actually missing. Just remember, library, check out books. Don't modify books in the library and stuff like that. All right, so now we have a space to save it. Save. Do it over again. Let's try a new program. So what we'll do next is to kind of mix and match things a little bit. In other words, I have something that's passed by value, and then I'll pass it again by reference to somebody else, and vice versa. Okay, I'll get something that's passed by reference to me, and I'll pass it by value to somebody else. All right, but we'll separate it into two different programs. Initialize. Okay, by reference x gets 0, and define sub. So this is not a very useful subroutine, but it's good for illustrating the concept that we are talking about here. And then we'll define stub. Define sub stub. And from now on, you will see that I use the stub subroutine or the main subroutine, if I will, a little bit more often. So I will say this is a local variable to me, local I, and I will say invoke initialize. I specifies parameter x, and x gets x plus 1. I gets I plus 1, and define sub, invoke main, just like that. Fix the indentations. So, all right. So here's our first sample program, and it kind of mixes the concepts of a local variable and the concept of passing by reference. Okay? And from now on, you will see that I will use this quote-unquote concept of the main subroutine more, because that's what you will see in cisp300. In cisp300, there is no such thing as the first line outside of the definition of a subroutine, because everything has to be in a subroutine in C and C++. Well, if everything has to be in a subroutine, then where do we start the execution of the program? What do you think? Main, exactly. The main subroutine is quote-unquote automatically called by quote-unquote the system. So that's the beginning point of execution. So we're changing the way we structure our programs just enough to incorporate that concept in cisp360. All right, so let's go ahead and trace this program. It's not very, exciting, but it will, illustrate the concept that I need to illustrate. And we need to resize it again. All right, line number. Do we have any global variables in this case? Well, we have two names that are used in this program. We have I and X, but both are not global variables. We know I is not a global because we say it's a local. We know X is not a global because it's a parameter. Parameters are not global variables. So we have no global variables whatsoever in this program. So that means when we start this program, we really only need column A to remember the line number. The precondition, well, technically we still have to say what is the precondition, but since we don't have any global variables, it doesn't really have a meaning anymore. Then we start on the first line that is outside of the definition of a subroutine. In this case, it's line 10. Invoke main. Okay, that's easy. The return line number is post. But we also need an extra column. We need an extra column for what? For local variable I, which always starts with an unknown value. That. And after we set up columns B and C, we can go into the subroutine. The subroutine main, the first line that is useful, that actually does something, is line 7. We go to line 7. Line 7 invokes another subroutine, so we have to allocate another column for the return line number. It also has a parameter. Parameter x needs its own column. Let's deal with the return line number first. The return line number of this invoke is line 8 because the invoke is on line 7 itself. That's easy. X is passed by reference. So that means X has no value by itself. It is a reference to another column. So in this case, X is also known as which column?
C.
Column C. Very good. That's where I was. So when you look at line 7, when you look at this line here, you can read this as invoke initialize, use I to specify X. That's how I would read it, is to use I to specify X, so X becomes an alias to the column of where I lives. Okay? I as in the variable, not I as in me, I. All right, are we doing okay so far with these concepts? Moving on into the subroutine. The subroutine only has one really useful line, which is line 3. Line 3 initializes X to 0. So we store 0 into X, but I cannot change column E because column E is really just a little call number to find the original item. The original item is living in column C, so column C is the one that I have to change to 0. Then we move on to column 4, line 4 of the algorithm. Line 4 of the algorithm is the end of a subroutine. 2 things to do. 1, to remember where to continue execution, which is line 8. 2 is to deallocate the columns that were allocated earlier. So we also have to remember that these are no longer in use by using a strike through, like that. And now we're back to line 8. Line 8 wants to add 1 to I. I is column C. We add 1 to it, it becomes 1. Then we move on to line 9. Line 9 is the end of the main subroutine, so we have to do the same thing, which is to deallocate. Okay, first thing is to remember where to go to first before we deallocate that column. And then we can deallocate both columns, both the return line number and also the local variable. And that's the end of this execution. Yep?
So to cross them out, you would right click and then go to format cells.
Yeah, that's how I do it. You can probably program a shortcut to do it. So the way I do it is, I just, highlight, copy and paste it first, and then I highlight both columns. You can do a Control or Shift click in this case, and then right click, go to Format Cells, and then go to Font Effects, and use strike through to select single. And then click OK. It strikes it through. Okay. And because this is something that we use quite often, if you want to use a hotkey, you'll program a hotkey to do it, go ahead. And that's probably a good idea. Okay. Any questions about this? No questions? Okay. So let's go ahead and save this program. So I'll call this local to by ref because we use a local variable to pass by reference to another subroutine. Before we go any further, I want to show you where to find the notes. Okay, where do I find notes that talks about this sort of thing? And it is here. You can read the rest here, but the best place to start is actually updated subroutine notes. I would go ahead and open it up. Open, and you will see all the concepts that we have talked about so far and will talk about are actually here already. And this is using the same notation that we use in class, so this is actually pretty good, pretty useful. So where we are right now is we have just gone through the basic idea of passing by reference. So when you look at this, it uses the same sort of notation. You can see the strike through. And over here, I have an extra column for explanation so that you can see what is happening when a particular line executes. But it's basically explaining the same stuff that we are talking about at this point. Are there any questions? Yep.
Yeah, I was looking when you clicked on it, it showed the subproofs. Are we going to be able to access that? Because I know.
Yeah, subproofs is still active. Okay. I only use it to store my class notes, but Moodle is not there anymore.
Okay.
So Moodle is now inside a district server, because we value your privacy, your grades, and stuff like that. So it's now inside the district infrastructure. But the class nodes has no privacy issue whatsoever because it's really just
Gotcha.
content that I need to use in my classes. So I'm still hosting that on a different server.
Okay.
Yep. So even when Moodle is down, you still have access to the class nodes. All right. So let's go back to our sample program, and we'll go ahead and use a different program to illustrate a different concept. So let's start from scratch. It's a new program. Find some. Let me make a mistake here first. Okay, so there we go. The whole program, but it has a problem. So don't just copy everything. Let me explain what the problem is. This one explains how to pass by reference to pass by value. Go. All right, so let's go ahead and trace this code. The precondition has nothing to say. We do not have any global variables. Then we go to line 14. Invoke main. The return line number is post. It also has a local variable I, which starts with an unknown value. So this stuff is about the same as last time. When we get into the subroutine main, we go to line 11. I gets a value of 0. And then we get to line 12 to try to invoke G. The first part is easy. The return line number is whatever line number is after the invoke statement. In this case, it's line 13. And we have a parameter to pass, so X as a parameter needs its own column. In this case, it's column E. What do I put here? What am I using to specify parameter X? A constant. Does a constant have a column associated with it? No. Nope. So you cannot do it. Okay, that's the problem. Okay, this is a problem with this program. Is that 5 as a constant does not really have a column to store itself. It's a constant. So that's why this program is not going to work because I'm not using a variable to specify pass by reference. So whatever is on the left-hand side of the double-sided arrow has to be something that specifies storage. In this case, local variable I has storage, so I can use it to specify parameter X. And once I fix that problem, I can say X is also known as column C because local variable I lives in column C. Are there any questions about this behavior? Why the original program had a problem?
On line 13, you mean and define main?
And defines subroutine main. That's usually how we do it. All right, so now we are in subroutine G. Subroutine G is up here. I'm going to line 3. Line 3 is invoking subroutine F. So that means we need a return line number and also one column for parameter I. The next question is, what do I put in column G? The return line number is the easy one because we just specified the next line, which is line 4. Parameter I is passed by value, but I'm using a parameter that's passed by reference to specify something that's passed by value. First of all, is there a problem? If I just evaluate the expression x on line 3, what should it evaluate to? Okay, we're on line 3, right here. If I just evaluate x all by itself, what should it evaluate to? Well, x is also known as column C. Column C has a value of 0. So x all by itself is going to evaluate to a value of 0. Okay? So what I'm doing here is to use the value 0 to specify parameter I. So parameter I, which is passed by value, simply starts with a value of 0. Are we doing okay so far? Is that okay? If you have any questions about that, why that will happen, you can just kind of imagine this. In other words, x is just an expression. It can be 0, can be x times 2, can be x squared divided by 2y, and whatever. It's just an expression to give you a value to initialize parameter I. So when I use x, you're not going to use aka something for I, because I as a pass by value parameter needs a value. And in this case, it has a value of 0. Are we doing okay so far with this? Okay. The rest of the program is not very useful because once we get into subroutine F, we start execution on line 7. Line 7 wants to add one to a by val parameter, which is perfectly fine. You can actually do that. Then we get to line 8. Line 8 is the end of the subroutine. We have to do 2 things. The first thing is to look up the rightmost return line number. It tells me to continue execution on line 4. The second thing is to deallocate both of these columns. Then we can go ahead and continue execution on line 4. Line 4 itself is also the end of a subroutine. So we have to do the same thing. Look up the rightmost return line number. It tells us to go to line 13 to continue. And then we deallocate both of these columns. And now we're back to line 13. Line 13 is the end of a subroutine again. So we have to continue with the same type of operation. Look up the rightmost return line number. It tells us to go to post. And then we deallocate both of these columns. And we are done. Are there any questions about this? No? Okay. So we have tried passing by something that's passed by reference. We pass it along to something that's passed by value. We have passed something that is, we have a local variable and we pass by reference to another parameter. What happens when you pass something that's passed to you by reference already and you pass it by reference to somebody else? That's the next question. All right, so we save it. We create a new program for that particular test. So I will say define sub. Okay, let's call it initialize. By reference x gets 0, and define sub. Define sub, pass along by reference y, and all it does is to invoke initialize and pass y along to parameter x of subroutine initialize. And define sub main, local I gets a value of, you know what? Let's try without initializing I whatsoever. Invoke pass along. We use I to specify parameter y in this case. And then we'll say I gets I plus 1. Find sub, invoke main. So here is our new program. My numbers. So we start execution here. The precondition, once again, has nothing to specify because we don't have any global variables anymore. In other words, we have just found a way to get rid of global variables altogether for most programs, not all programs, but for most programs. We go to line 14 first, and it invokes main. So we have to remember where to go back to. It is post. Main has a local variable I. As any global variable, it has to start with an unknown value. That part is that. Now we are in main. The first line we execute is line 11. It's nothing new. We have to invoke pass along. The first thing is to remember where to go back to. We have to go back to line 12 because the invoke is on line 11 itself. That's easy. And we also have to pass a parameter to parameter y. It's passed by reference. We are using I to specify y. Local variable I is living in column C. So y as a pass by reference parameter is also known as column C. This part we have already practiced quite a few times already, so it's nothing new. And then we continue execution in pass along, which is on line 7. Now the question is, what do we do here? On line 7, inside pass along, we are going to invoke initialize. And we are going to use y to specify parameter x. Let's do the easy part first. The return line number is the line number that is right next to the invoke statement. The invoke statement is on line 7, so we have to return to line 8. That's the easy part. The really kind of, I wouldn't call it tricky, but what I really want to illustrate is, what do I put here? It looks like we have two choices here. We can either specify that parameter x is also known as column E because we are using y, which is living in column E, to specify the new parameter, or we can refer all the way back to column C. Okay, do you guys see the two choices? Okay, let me just write it here so it's more clear. First choice is AKA column E. Second choice is also AKA column C. Only one is the correct answer. So you have to ask this question. The library example really helps because okay, let's just say that I'm the spell checker, but I want to also pass the book along to somebody else to check for a grammar. Okay. So I'm only working on the spell checking, but after the spell checking, I want to pass it along to someone who can check the grammar, of the book as well. Okay. So what am I going to pass along to the other person? Am I going to pass along a call number to find my call number to the book, or am I going to just say, oh, here's the call number of the book itself. Go find the book yourself and fix it. The first approach or the second approach? The second approach. Okay? The second approach, which means I'm just saying, oh, here's this is how I find the book, and this is also how you will find the book. So the other person doing the grammar check is not going to have a reference to find my reference and then go find the book, because that person will have a reference number to the book itself directly. So in this case, which one should it be? Also known as column C. Now this part is very important because I know that it's going to be, because conceptually, when we pass by reference, we have to refer to the reference point of whatever is on the right-hand side. I mean the left-hand side of the double-sided arrow. When you pass a pass by reference parameter by reference again to somebody else, you are just passing the reference itself along. You're not passing the reference to the reference. Are we doing okay so far? If you remember the book and library example, there is no such thing as a call number to a call number. Okay? So that should give you an idea of, oh, okay, if I want to pass the way to find a book again to somebody else, I'm just using the call number, not a call number to a call number. Okay? So that makes things a whole lot easier, because by the time we get into the subroutine, initialize on line 3, it refers to X. Okay? X is also known as column C, and we know right away what to modify, because we know that we have to go to column C and change that to a 0. Then we go to line 4, the rest is really quite boring because we're just returning our way out. So we have to deallocate these 2 columns. I really need to make a shortcut key to do this. On line 8, we're doing the same thing. It's the end of a subroutine. We continue on line 12. And then deallocate both of these columns. Paste. And then back onto line 12, we are adding 1 to I. So I goes from 0 to 1. And then we go to line 13. It's the end of the subroutine. We continue at the post. And then we also deallocate both of these columns. And oops, forgot to paste first. Paste. Do the same thing. There we go. And that's the end of this trace. Are we doing okay so far? Let's go back to our recursive implementation of factorial and see how we can incorporate what we have just learned so that the factorial program does not need any global variables anymore. Okay. So we'll go ahead and save this.
Quick question.
Yep.
So for this algorithm, we didn't get anything at the end. The I we still cross out, right?
Correct. This program is not designed to do anything useful. It's only there to illustrate how do we pass a parameter that's passed by reference to me, so I can pass it along to somebody else, also by reference.
Okay.
So I call this by ref to by ref, because it's passing something by reference to somebody else by reference again. All right. Now let's go back to our program, our favorite algorithm, factorial. This time, let's see how we can do it recursively, but without the use of any global variables. Find sub, factorial, by val n, by ref r. And then we can say if n is greater than 0, then we want to invoke factorial, n minus 1 to specify n, r to specify r, and then r gets r times n after returning from the recursive call, else r gets 1, and if, and define sub, we'll fix the indentation. So define sub main, local variable, I don't know, call it x. I don't even need to initialize x. We just say invoke factorial. We will find the factorial of 3 just like before. 3 goes to n, x specifies r. And if you want to, we can just print the result just so that we have something to do after that. And define sub, invoke main. Go. And this time we have no global variables anymore. Yay. All right. Well, this is good news. Getting rid of global variables altogether is definitely good news. I think any programmer should have a chant before they start programming. Starting with global variables are evil. Do not use global variables. And it works even better as a group. You can kind of imagine a group of programmers, either at Google or Microsoft, chanting, global variables are evil. Do not use global variables.
That helps with their image. That helps with their image.
Yes, definitely. and if they spot any programmers, using global variables, there'll be virtual stones. Yeah, everybody will go to the Facebook and dislike. All right. Well, the nice thing about virtual stone versus an actual stone is you can automate it. All right. So let's go, trace the program and see what it's going to do. Well, the nice thing of using a program that we are already familiar with is we already know what the program is supposed to do, but we can now focus on the mechanism that is new to us. Okay? So we'll go to sheet 2 here. We do need comments because we have conditions to evaluate. We have line number, we have pre, but you know what? We don't have any global variables anymore. That's nice. And then we go to line 16, we invoke main. Okay, this part is kind of boring. Return line number is posed. Main has a local variable x, which starts with an unknown value. Then we go into the subroutine main, which is starting on line 13. Line 13 is invoking factor or factorial. Okay, fine, I'll just spell it the whole thing. Factorial. And that's going to be another return line number allocated. And this time the return line number is line 14 because the invoke is on line 13. Move on to column F. To specify 2 parameters this time. One parameter is called n, the other parameter is called r. N is definitely the easy one because n is passed by value. When something is passed by value, what you need to specify the value is on the invoke line itself. It is 3 in this case. R is passed by reference. So we want to find out what X is specifying as a storage or a column, and then use that to specify R, so it's an alias of that column. X is a local variable. It is living in column D, so R is now an alias of column D. Are we doing okay so far? Okay. So once we set up the 3 columns, we can go into the subroutine. The subroutine factorial starts on line 4. That's the first line that has something to do. It evaluates a condition. N is greater than 0. Oops. N is greater than 0 is, what do you think? True. Okay. So we go to line 5. Line 5 is going to invoke factorial again. I think I was trying to shrink it a little bit because this will take up more columns than before. So we go to line 5. Line 5 is invoking the factorial subroutine again. So once again, we need 3 columns. Okay, so we need these 3 columns again. And what I'll do. All right, so that's the invoke is on line 5. The return number is going to be on line 6. That's the easy one. What do we specify n? How do we specify n in this case? The line is on line 5. We are trying to deal with this part here. N minus 1 will give me the value to specify the value of n. It sounds kind of circular, but it's not. Because the n minus 1 on the left-hand side of the right arrow refers to the n that we already know. The n that we already know is column F. Column F has a value of 3. 3 minus 1 is 2. We then use the value 2 to specify the n that we are trying to set up here, which is column I. So column I starts with a value of 2. What about R? R is going to specify R, which also sounds kind of circular. So what are we doing here? Now, once again, the R on the left-hand side is the R that we already know. What is the column corresponding to the R that we already know? Is column G. Okay, column G is the R that we already know. It is already specifying, an alias to a certain column, which is column D. So we just pass that alias along, so that the new R, which is column J, is going to be an alias of the same column. So column J will also be known as, also known as column D. It's an alias of the same column. Are we doing okay so far with this concept? Okay. Is that really okay, having column G and column J both being aliases of column D? It's perfectly fine. It's no problem. Because each one is just a little slip of paper with the call number to the same book. It's not a problem. So now we go back to line 4 again, because we are starting the execution from the beginning of a subroutine. Line 4 is saying, is n greater than 0? N is greater than 0 is true. Then we go to line 5. The rest of this program is kind of boring. So I'm going to use this mechanism here so that we can kind of just focus on the part that we need to focus on. In fact, well, we kind of need this one to stay a little bit later on because it will be useful. But for the most part, it's just copying and pasting, except the value of n changes. So now we can scroll to this part. Then we go back to line 4 again. N is now 1. 1 is greater than 0. It's still true. Then we go to line 5. We invoke factorial again. So we just copy and paste the columns. Except n is now 0. So when we get back onto line 4, in the last invocation, n is greater than 0 is now false. So that means we don't go to line 5 anymore. We have to go to line 8 for the else. Line 8 is going to make R 1. All right. So we look up R. R is an alias of column D. We cannot change column P because column P is a parameter passed by reference. We cannot change column P, but we can change what it is referring to. So that means we are going to go to column D and change column D to 1. Is that okay? All right. After line 8, we have line 9. Line 9 is the last line of a subroutine, which means we have to return. We pick the rightmost return line number, which is line 6. So we know we have to continue on line 6, and then we know we have no use of these 3 columns anymore, and deallocate.
Is that line 9 or
Line 10.
Or line, yeah.
10.
Oh, it's line 10, sorry. You're right. Line 10, and then we deallocate these 3 columns. And then we continue execution on line 6. Well, because NOP, columns NOP are no longer in use, I'm going to scroll them off a little bit so I can expose columns K, L, and M. We are back onto line 6. Line 6 wants to calculate the product of R and N and then store it back into R. N is column L, has a value of 1. R is also known as column D. Column D has a value of 1. 1 times 1 is 1. We store the 1 back into into R. R is an alias of column D. So column D gets updated again to a value of 1. After line 6, we go to line 10, because that's the end of one branch we have to get out of the entire conditional statement. And it's going to be the same thing. We deallocate the columns. We continue execution on line 6 again. Columns K, L, M are no longer useful. We scroll the screen a little bit off so we can now refer to columns H, I, and J, and do pretty much the same thing. Line 6 wants to calculate the product of R and N. R is an alias of column D. Column D has a value of 1. N has a value of 2. 2 times 1 is 2. We store 2 back into R, which is referring to column D. So column D is updated to a value of 2. And then we go to we go to line 10 again, deallocate the 3 columns. You can see this part is really kind of boring. And then we continue execution on line 6. Line 6, once again, wants to compute the product of R and N. R refers to column D. Column D has a value of 2. N has a value of 3. 2 times 3 is 6. We store 6 to R. Once again, R refers to column D. So column D is now updated to a value of 6. We get out of the conditional statement. We get to the end of the subroutine. We deallocate the 3 columns. And then we continue execution based on this on line 14. Line 14 just wants to print the value of X. We don't really have an output with a trace like this, so I will just use the comments column to say that we are printing a value of 6 to the screen, or whatever device you want to print it to. After line 14, we get to the end of the subroutine. So this time we are at the end of the main subroutine. We have to continue execution at post, and then we don't need these 2 columns anymore. We deallocate these 2 columns. Oops. Format, strike through, and we're done.
Is that for 15 or 14?
Sorry?
On the strike line?
Oh, okay, I got it wrong again. We get to line 14, but this part is done on line 15, sorry. And then we get to post after line 15. Sorry for that. Yep.
Can you minimize it for just like 2 seconds?
It's already minimized. Column D and column.
No, I mean the whole sheet, the spreadsheet.
Oh,
The whole thing.
sure. Absolutely. Like that?
Without that line between the.
It's not really doing anything. You realize column D and column E are now adjacent.
Okay. Yeah, I just keep it for you too.
It's like playing Portal, except it's an actual door. I'm going through the portal, but oh, it's the same place.
Okay.
It's a wormhole that leads to the next, adjacent space. So are we doing okay so far? The most important part of this program is to focus on column D, because you can see that in different invocations of factorial, column D is updated again and again and again. Okay, so that's the important part. And this is also how we got rid of global variables, because we were using a pass-by-reference parameter so that we can say, oh, okay, use whatever this parameter is pointing to store the result. And that's how we got rid of global variables altogether, which is nice. Are we doing okay so far with this program? There's only one more concept related to subroutines. It's called a return value. All right? So let's go ahead and, I'm going to save this program first because I know this one is going to be important. So we'll probably refer to it, wrong place. So I call this factorial again, but this factorial is different from the other factorial programs that we have done so far. All right, so let's go ahead and close this. Let's see. I'm just looking at the clock to try to determine, what is the best way to explain a return value. This. All right. So let's try to do something that is really redundant. Define sub add. Okay. Now, when you add 2 numbers, how many things do you think I need in order to implement add? Just based on the concepts that we have talked about. We need 2 as the input, but we need 1 as the output. Okay. So that means, we need something that looks like this: by val, x, by val y. But we also need a by reference, something else to store the result. So I would call it r. And then we will say R is x plus y, and define sub. If you want to do multiplication this way, same thing. I mean, it's really just quite boring. Define sub mult by val x by val y, because when you multiply, you need two numbers to multiply. But you also need to specify where you want to store it. So R gets x times y in this case, and define sub. So if you want to use subroutines this way to calculate, addition, subtraction, multiplication, and division, it's very tedious, because every time you want to, add something or multiply something, you need to find some place to store that intermediate result, which is very cumbersome. Okay. So if I want to illustrate this using a text program, using a mouse pad here, think about what you have to do when you try to calculate something that looks like this. 2 plus 4, 5, and then the whole thing times, 6. Okay? And we already know the result is 42, right? But we don't have a way to do this using just passing by value and passing by reference. The reason is after you compute 2 plus 5, you need a place to store the value of 2 plus 5. And then after you calculate 7 times 6, you also need a place to store the value 7 times 6. You cannot just say, oh, print this value out. There's no way to do it. In other words, in this case, the best way we can do it is to say x gets 2 plus 5, and then we'll say y gets x times 6, and then we'll go ahead and say print the value, the final result, which is y, instead of print 2 plus 5 and use it right away for the multiplication, and then use the product right away for printing. Am I kind of illustrating the concept or the limitation, at this point? Okay. But who would be so dumb to re-implement add and subtraction and multiplication and division? Well, maybe those are different operators. Maybe you're defining a new operator that is not built into the program. Okay? But you still want to be able to utilize the result of the calculation right away without having to store it in something else. Okay? Am I still making the point okay? Okay? So with calculations, we want to be able to use it right away for another operation like that. Okay? Now, before we move any further, I want to explain, the different ways of writing expressions. What do you mean by writing expressions? Well, this is an expression, right? And how many people have problems understanding what this means? No problems? Okay, let's make it harder. How's that? I mean, isn't that more complicated? No, not really? Okay, I can make this even more complicated. How's that? Well, obviously it's not 42 anymore, but do you understand what that means? What do you have to do to get the result of this calculation? We know that stuff, right? The question now is, what if I tell you that the way you have been taught to deal with expressions is all wrong to begin with? The concept of this is called infix notation, which means the operator is between the values that you want to operate on. And I'm going to tell you and say there are better options out there. This works okay, but this requires the use of parentheses a lot. Okay? Okay, the first thing I want to talk about is called the prefix notation. The prefix notation means the operator appears before the values that it has to operate on. Okay, so using a prefix notation, it means 2 plus 3 will become plus 2, 3, because you're specifying the operation first, and then you specify the values that you want to operate on. Okay, so that means the expression that we are dealing with, you have to start with the outermost, the last operation first. So in this case, it's a division, you're dividing something by 2, and that something that you're dividing is the result of an addition of something and 1, and then the other part is a product of something and 6, and the innermost part is 2 and 5. This is called the prefix notation because you're specifying the operator before the value that is operating on. And then you will say, but Tack, I thought you said something about removing parentheses, and this one does not remove parentheses. There's a significance to this notation. This is called the prefix notation. Is used by programming languages like Lisp. Okay, the chances are you guys probably won't have to program in Lisp, and that's lucky you, because I had to program in Lisp when in graduate school, and matching parentheses becomes important. Let's just say. All right, so. But I did promise you that I can get rid of parentheses altogether. And that's by using a notation that we call, well, you guys can guess it, right? We talked about infix, which is what we already know. The operator is between the values. We then talk about prefix, which means the operator is before the values. And what do you think is the last one? Postfix, right? All right, so let's go ahead and give these guys names. This is prefix notation. What we usually use is called the infix notation because the operator is between the values. Now we talk about the postfix notation. Postfix notation means the operator is specified after you specify the value. You say 2, 3 plus to mean 2 plus 3. Okay? So I'll just say 2 plus 3 is now specified as 2, 3 plus. All right. This is the funky one, because this is the one that requires no parentheses. So we'll go ahead and try to deal with this expression here and re-express it using the postfix notation so that we don't have any parentheses whatsoever. All right. There are several ways to specify it. Okay, the first thing is to specify the operation of the plus. So you can say 2, 5 plus. That will give you the sum. Then you say 6 multiply, 1 plus 2 divide. That's it. Okay, now let me read this out again. You specify 2, you specify 5, so you have 2 values, and then you specify plus. So now you take up these 2 values, you calculate the sum, and the sum becomes a single value again. The sum of 2 and 5 is 1, and then you say 6, now you have 2 values again. You do a multiplication, it consumes the 2 values that you have specified, but it does give you something back. It gives you the product. So now the product is available. You specify another number, which is 1. Now you have 2 values again, right? And then you perform the addition. So you now have the sum of 1 and the product that you have calculated earlier. That becomes 1 single value. And then you add another value, which is 2. Now you have 2 values again. And then you can, with 2 values, you can do a division, because the first one is used as the dividend, and the second one is used as a divisor. And once you perform the multiplication, you have the quotient. And as promised, no parentheses. Okay? So the next question is, who's going to be so crazy to use this kind of postfix notation? Well, you might have, a relative, maybe your dad or your uncle or somebody else, who's an engineer, who grew up with HP calculators. Ask that person what is RPN, reversed Polish notation. Okay, and this is how they use calculators, up until at least the 80s. Okay, HP made scientific calculators that used the RPN or reverse Polish notation, which is just like that, up until at least the 80s. I think it goes all the way to the mid-90s. Okay, so we have an entire generation of engineers who can compute, who can transform something that looks like this into something like this in their mind without any paperwork. And I think the reason is because HP doesn't want to deal with the parsing of infix and the parentheses notation. Because the parsing, which means the analysis of something like this to extract the structure and the order of operation is actually somewhat complicated. The earlier calculators do not have the processing power or the resources to do this type of parsing. So HP is basically just saying, oh, I'll leave it up to the people using the calculator to figure out the order. And all they have to do is to implement something that looks like that. It also saves 2 keys on the calculator keypad because you don't need the open and the close parentheses anymore. Okay? All right, so, but I'm talking about all of this stuff for a reason, okay? The reason why I'm talking about this is, well, it's two-folded, but I'll only talk about the first one first. When we talk about the infix notation, this to me looks like a subroutine invocation. Okay, just kind of imagine invoke add 2 goes to x, y goes to 5 goes to y. That's an infix notation. Okay, but there's one thing that's missing from our discussion of subroutines. There's no way for me to utilize the result of one invocation directly as the parameter of another invocation. Okay, we can pass by reference, but passing by reference still means that you need a place to store the result of a previous calculation. I cannot utilize the result like right away. That's the concept of a return value. So if I go back to the class notes here and go back to the notes that we are supposed to be reading, is in section 7. Section 7 talks about returning a value. And we start with something very simple. We define a subroutine called 7, S-E-V-E-N, and the only thing it does is to return an actual value of 7. And the main part of the program is just printing the value of 7, which is the return value of the subroutine 7. Okay, so we start with something like that, really simple, but it's already kind of complicated because the way we set up the return info, not return line number anymore, is a little bit different. So this is a quick preview of what we'll talk about on Thursday, because this is the last topic of subroutines. Okay, and subroutines is probably when this is combined with other things like recursion and having multiple invocations in the same on the same line, this can get a little bit confusing. But remember, it's not, if you don't focus on the representation and only focus on the basic mechanisms, you'll be fine. So we'll talk about this on Thursday. Okay? You might want to read a little bit ahead of me because it's a little bit of a meaty topic.